Hello, welcome to In 5 Minutes. Next is a JFET design problem. In this again we can identify, since the arrow is pointing inwards, can say it is N channel JFET. For any problem, when we start for the analysis, first we identify which is the channel and which is the configuration. Which are the three configurations? Can say it is common source configuration, can be common drain configuration, or common gate configuration. Now as per the symbol, it is JFET, and in this is your gate terminal, this is your drain terminal, and this is your source terminal. Now you can say, where is the input applied? Input is applied to the gate, and from where we are taking the output? We are taking the output from drain, so it is common source configuration. Right, now what is given in the question? Let us see. In this, the parameters of the transistor in the JFET common source. Now even if we not read common source, we have already found it that it is a common source configuration. Might not be given in any problem which is coming in the paper. Now IDSS is given as 8 milliamperes, VP is given as minus 4.2 volts, lambda equals to 0 implies that output resistance we need to consider it as infinite. Why? Your output resistance is 1 upon lambda into IDQ. Since lambda is 0, so 1 upon 0 will be infinite. Now the value of VDD is given as 20 volts in the question. RL is given as 16 kilo ohms, and they have told us to design the circuit such that the voltage at the source is given as 2 volts, R1 plus R2 as 100k, and the Q point, we need to find this value at the Q point where your IDQ is IDSS by 2. So what will be the value of IDQ? IDSS by 2, that is 4 milliampere, and the value of VDSQ will be VDD by 2, that is VDD is given as 20, so this will be 10 volts. So we need to use these two values. Now for the DC analysis, what is happening to the capacitors? The capacitors are open circuited. Why? In this case your XC for the capacitance is infinite. For zero frequency it is infinite, so this capacitor will be open circuited, so this part will move out of the circuit. Then this part, since it will be open circuited, will move out of the circuit, so you are left with only this much part in your circuit. So redrawing the part, what all you have? You have the resistance R1, then you have the resistance R2, then you have the resistance connected over here as RD, and the resistance RS. This will be connected to ground. Here you have VDD, which is given as, how much is the value of VDD? 20 volts. R1, R2. We need to find the value of all the resistances. Now when you look at the diagram, this is your gate, this is your source, so this becomes your VGS, positive, negative. This becomes your VDS, and this is given as 2 volts. Right. Now the value of IDQ is given as IDSS by 2. So we have found IDSS is given as 8 milliampere, so 4 milliampere we have found out, and VDSQ is half of VDD, that is 10 volts. So when you apply KVL in this loop, we can find the value of RS. So what you can say, KVL to source loop, what will be the equation? VS minus IDQ into RS equals to 0. So VS will be IDQ into RS. So you need to find the value of RS, which will be VS upon IDQ. So this will give you, VS is given as 2 volts and ID is 4 milliamperes. So 2 divided by 4 milliamperes. So this will give you the value of RS as 0.2 kilo ohms. We have found the value of RS. Now we need to find out the value of RD.